This is an introduction to the Forest Manufacturing Model 230 vertical blade traveling table bandsaw. I've done other videos going into the details of Model 230. This particular machine has some interesting features, makes it worth a mention. The first thing you're going to see is that, well, you've seen any of my videos, you know these are traveling table bandsaws. Back up a step. So the 230 is a vertical blade bandsaw. These are high-speed machines. I'm running a blade speed of about 3,000 feet per minute. Can carry a blade up to 3/4 inches wide. And these are meant for cutting things like foam, insulation, plastic. I have customers also use them to cut graphite or all kinds of things. Basically anything other than steel or hard metals. Sometimes aluminum, but call me and ask about it before you actually try and cut metals on one of my machines. So, vertical blade traveling table saw. As a workpiece positioning aid, this machine has our adjustable workpiece positioning fence. Think of it like a very nice rip fence. So, turn the crank, moves in and out. This model includes an electronic digital readout to show where the fence is. You can program the units of measure. You can measure it in inches, centimeters, millimeters, furlongs, whatever you prefer. It also has the ability to zero. For example, you can move in, make a cut, zero the counter, and if you want to make it, the next step be 2 inches, move this 2 inches or until it reads 2 inches, and you know you've just moved the workpiece 2 inches. The upper guide position is adjustable. So we've got a hand crank mechanism here. Release the locking screw. Goes up and down. Lock it up. A note on the fence. So the fence, we normally make the fence height 16 inches tall. I do that because it means I get 3 fence sections out of a standard 48-inch piece of aluminum. This customer asked for a taller fence. They got a 21-inch tall fence. It plays hell with my material yield, but I made them pay for it. There's a potential for interference. This guide is adjustable, as I just showed you. But the guide here has some thickness. It takes about 2 inches. So I cannot run the fence any closer than about 2 inches to the blade when this upper guide is anything other than all the way up. If I'm over here, it's no trouble at all. I'll leave it up for now. A couple other interesting features. This machine has a pneumatic blade tensioning system. So you may not be able to see it, but over here there's an air cylinder. Most small bandsaws or medium size will use a screw over spring blade tensioning mechanism. It's reliable as an anvil. Everybody knows how to use it, and everybody uses it wrong. They don't use a tension gauge, they guess, they just screw it down, give it a couple thumps and say, yeah, sounds great. It's usually not. The better way is using an air cylinder, which is controlled on the back side where, I'm sorry, you can't see it. I've got a pressure regulator valve here with a gauge and a manual air control valve. So I set the gauge pressure. There's a chart with a manual that tells you for a certain blade, use a certain pressure. And then to tension, detension the blade, I've got a lever here. Flick the lever up, blade goes loose, lever goes the other way, and I'm tensioned. And I know I'm tensioned correctly. So you can change blades very quickly, flip, flip. You know you've always got the correct blade tension afterwards. It also makes it easy to detension the blade at the end of the day. Well, I recommend to preserve the wheels and the bearings and everything that at the end of the day, or when you're not using the saw for a long period of time, you detension the blade. The way I prefer to do that is disconnect the air source, unplug the air line, then detension and retension the blade. Because there's no air pressure, it won't actually move, but it'll let the air pressure slip out such that you'll take the tension off the blade but not actually move the wheel. It's a great way to preserve your wheel life and your bearing life, and with the pneumatic system it doesn't cause any extra effort. Of course the tension system, pneumatic tension system costs more, but totally worth it. so we got the fence. Another quirk on this machine, it has a 5 horsepower blade drive motor. That's about as big as you'd ever want to put on this machine. We're running a blade speed 3,000 feet per minute, 5 horsepower. It's going to cut through just about anything, which I will demonstrate. Another quirk, and this is something I don't actually recommend. I don't know if you can see it here. This machine has a foot pedal. So stomp on the pedal, machine starts, release the pedal, machine stops. Normally we use a magnetic motor starter with what they call 2-button through-wire control. So normally you have a start button, you push the start button, it moves, runs, until you press the stop button to stop it. We still do have a magnetic motor starter with an overload. So if you overload the motor, which with a 5 horsepower motor you're not going to do, it'll trip out until you manually hit the reset button on the starter. This takes the place of the start-stop buttons. The reason I don't like it is it might encourage the operator to start and stop the blade more frequently than necessary. A little bit of electrical theory here. Electric motors like this one, it's called an induction motor or scroll cage motor. Every time you start the motor, it gets a big surge of amps and it heats up a little bit. And then when you release it, in this case, we have a brake motor. You may have noticed here, start the motor, starts just about instantly, stop the motor, and it stops just about instantly. The stopping just about instantly is because we have a brake on the motor here with friction material, just like a car brake or clutch or something. If you start stopping and starting the motor too frequently, you're gonna build up heat in the motor. If I sit here and start and stop this thing every 5 seconds, every 10 seconds all day, you're gonna cook the motor. It's gonna build up the heat from every start-stop cycle, but it's not gonna have that steady state running to let it cool back off. It actually runs cooler when it's just running than when it's starting. So if you start and stop it too often, you're potentially gonna burn out the motor and wear out the brake friction material too often. The friction material is no big deal, a couple $100 to replace the friction material, just like car brakes. If you burn out the motor because you cooked it or overheated it, definitely a bad thing. $1,500, $2,000 or so to replace a motor. So you can do this, I'll do it for you, but just know that if you start and stop it very frequently, I believe the motor manufacturer actually rates the motor for 3 start-stop cycles every 2 minutes. If you start and stop it much more frequently than that, you'll burn the motor out. Why do you want it? It lets the operator control the machine hands-free and turn it off at any instant. Instead of being over here working, I'm done, I want to turn this off, reach or step over here, hit the stop button. Instead, just lift your foot and it's off. Or, God forbid, in case of an accident, something happens, just lift your foot. So there are advantages to this foot mechanism, but there's big disadvantages also. Please spec out your saw responsibly, understanding that. So let's do a quick test cut here. What I've got today is not what this particular customer is going to be using. I've got some big pipe sections. So this is a chunk of PVC pipe. I've already obviously done some test cutting on this with this machine, but as a demonstration cut. So a couple ways you can do this. You can set the fence, whatever, say I want to cut off 6 inches, I move this until it says 6, stop, and then I can push the workpiece up against the fence, or I can go way back here and use the fence to move the workpiece. Either way works. As long as your workpiece is not terribly heavy, this works fine, moving the workpiece. Now, if this was a big chunk of something really heavy, and you try to push it with a fence, you might strip the gears out or something. But for something like this piece, well, relatively light, as with this piece of pipe, sure fine. Move it using the fence. Next step, lower your upper blade guide until it is just above the workpiece. Eyeballing here. It does 2 things for you. First off, you're shortening what I call the working blade length, the length of blade between the guides. Keeping that shorter helps make sure you get good results. Also, it means that the part of the blade you're not using is guarded. Just bear in mind, we do have that potential for interference between the blade guide and guard and the fence. Here, I don't have that problem. Next thing to look at. This stuff's actually really tough to cut. I may have to lean, from previous experience, I can tell you, I will have to lean into this a bit to cut it. But that means there's also the possibility of the workpiece sliding back as I cut it. The way I get around that, magnets. This is what we call a welding magnet. We use them in our shop all the time. Just put it behind here. I'm actually gonna grab a second one. To prevent the workpiece from sliding backwards as I cut it. So now we'll do a cut. I'm just checking. Always start the saw motor when the blade is not touching the workpiece, and then ease the workpiece into the blade. I've got my foot pedal here. Start the motor. This stuff is actually pretty difficult to cut. I've got to run the dust collection system. This machine has, you can see the blue fluff flying everywhere. This machine has what we call a dust nozzle, which is basically wraps around the blade below the table at roughly at the point where the blade exits the workpiece. There's a big butt here. You can see right here, I've got this arc shape. So if I'm cutting right here and right here, the blade is actually the workpiece on top of the table, and the dust nozzle is really effective. When I'm cutting right here, there's a big area for the dust to float away and not get caught by the dust nozzle. I'm gonna back up just a little bit so I don't start the blade while it's touching the workpiece. Should be a little less dust produced now. Back into the cut. That's what you get. These little flatness tests here. Beautiful, perfect, dead flat. Perfect. So that's it, model 230 with upgrades, including a 5 horsepower blade drive motor, foot pedal on off, pneumatic blade tension, workpiece positioning fence with digital readout, and a 21-inch tall fence. If you have any questions, or like to discuss a specific application, please feel free to call or email us here at Forest Manufacturing. Thank you for your time.